So for anyone that wants to access the shared Google Drive, which actually includes that Google Doc that I showed with the schedule, you can either use the tiny URL, which is CHBC EduBof 2024, or you can scan that QR code. I'll give you 30 seconds to a minute if you want to. Otherwise, just have faith that we are sticking to schedule. My colleague that's the timekeeper doesn't appear to be here, so I will, can someone volunteer? Kevin, you're very good at being strict. I've got a 5-minute timer. So I will try to be strict with the time. So if you are speaking, I may cut you off. I'll try to give you a 2-minute warning. It wasn't my intention to be the timekeeper, but I am. So this session today is for anyone in HPC that is a trainer, a learner, an educator, an academic, or anything else that you think fits with the moniker HPC education. So we've had this session every year here and at SC in the US and at ISC in Europe. But a problem we identified back in 2022 was that we have this meeting, which is a 1 hour or a 90-minute meeting, and then we take a break for a year. And we tried to break that problem. So this is a problem some of you may not know that we've had, but we want to create momentum that stands outside of just the session that we hold for an hour or an hour and a half. So we created 2 communities of practice back in 2022. I will include QR codes for these 2 groups at the end of my slides. And that Google Drive URL that will also be shared at the end of the slides again gives you access to these presentations so you can still join the group. But for anyone that wants to quickly do it, it's tinyurl.com, and then there's EduBof CHPC 22, which will join the African Communities of Practice Google group, and then there's a US initiated one, which is a global one. So if you join those, you can have discussions about any tricks, trends, challenges you might have, or events or opportunities to do with HPC education. I am slipping to the next slide now. Don't panic if you don't get this. We will be presenting the QR codes at the end. So what I will talk about very briefly is the Cloudless Cluster Virtual Lab. For those that don't know, we presented a paper at SC23. My project has developed what is a downloadable 3-node virtual cluster that you run on your local machine. No more trying to struggle with cloud credentials or limited time on a cloud resource or a production system. Normally when the training ends on one of those systems, you lose access and the people can't continue their learning. So we developed a product that you can download to your local machine and you run all your training there. I'll give a little more insight. The session is not about me talking about this product. It's just giving you some feedback for the last year. So there is a link to the paper that gives more insight. But for those, the reason that I'm talking about it here is just the 1 year in review since we launched OpenHPC 2. So the OpenHPC 2 lab was launched in November 2023. We're pretty much a year later. Can't really count 2 days in December. We've had 1,000 users globally use that virtual lab for training, and the vast majority have been US and South African based, but you can see that we've had a heat map pretty much over most of the planet. We ran 4 virtual labs for this and 2 on-site training sessions using this resource. But that's not to say that people can't access it anytime they want. So it's available 24/7. It's a Git repo, and you can run it in your own time. But the facilitated classes with dedicated teaching assistants, we've run 6 such labs in the last year. The last training, we hit 80 people online. Again, the majority were the US and South Africa. And we had fairly decent representation, across the spectrum. Some may say that's not enough, but at least we got something. The fun facts about that lab, we've developed a self-certification tool, so people that complete the lab can certify themselves that they've completed it. It generates a PDF using a Node.js script on a public website. Basically, you run a few test scripts to verify that the cluster is running, and then it generates a ciphertext with your name, and it can only be decrypted by the PDF generator. It has been evolved into a fully functional downloadable cluster. You don't have to learn how to deploy the cluster, which was the intention of the lab. Now you can download a pre-packaged cluster and actually do your own training if you want to teach people how to do MPI or code compilation or things like that. And it has been done. I think it was the summer school, Benjamin? Yeah. And we are working on OpenHPC 3, which is a new version that was released in November at SC. It's a collaborative effort. Other people outside of our project are now getting involved with that as well, so we have a lot of US affiliates that are helping. And I ran it as a preliminary training cluster to help students entering the student cluster competition, because typically they get thrown into the deep end. first day learning Linux is in the competition selection round, and it's a huge disadvantage for those students that have never touched Linux. So this year I launched the class. I taught, well, supported 160 students on my own, so it shows it's fairly scalable. At the end, 5 students completed it successfully. That is to be expected because the training is geared for systems professionals, not undergraduate students that have never touched Linux and don't know how to spell HPC. But the point I'm making there is that we were able to do an entire 160 class facilitated lab with just me facilitating it. And the 5 certificates is not because I'm a bad teacher. So my time is up, which is perfect timing. OpenHPC 3, the boring facts is that we're working on the stack. There are a few challenges because we're trying to upgrade the software to be more advanced than what OpenHPC 3 is now. But for now, anyone can use the OpenHPC 2 virtual lab. I have to say thank you to the sponsors. And I will move on to the next speaker because this is my next section at the end. The next speaker is Reinhard and Lily. If one of you may come up and face the crowd. We'll take questions at the end. We've got quite a lot of time for questions. Cool, I'll give you your 10 minutes. Is that good? Did I do the right thing? Yeah, there we go. Cool. Oh, wait, that's not showing on the right screen though. There we go. What now? What do you, that one? Cool. I'll give you a 2 minutes warning.
Is there a way to like go? Hello everyone. I'm Lily de Mello. I'm from Wits HPC. I'm a second year computer science student at the University of the Witwatersrand. I've been with Wits HPC for 2 years now. 1 year as a participant, and then this year I'm an organizer, so I do a lot of administration for the group. And I'm also mentoring a SEC team downstairs. To introduce you to whom I'm doing this talk with, we'll hand it over to Reynard now.
Hi, yeah, my name's Reynard. I'm also mentoring a SEC team this year. I'm a biomedical engineering student, currently in my final year. I was part of the Team CHPC for ISC last year. And yeah, I think let's get into the talk.
Cool, so let's talk about how everything started. So Wits has always had a history with HPC, even before the CHPC was started in 2007. But in 2010, it became more official. We have something called the Mathematical Sciences Support Unit, and they started the interest group. And then in 2012, the student cluster competition was started up, and the inaugural winning team was made up out of 3 Wits students and 1 extra, and they went on to win ISC 2013. And this led to us getting recognition, and we could secure hardware sponsors, and this helped us grow our group to where it is today. Before 2021, we were focused a lot on just preparing people for the competition, but now we've expanded to trying to just educate the general undergraduate community. So that's how it started. Let's talk about what we're doing.
So I think a good thing is to talk about the training model that Wits uses, well, the SIG uses to train students for not only SEC, but everything we do. The Wits training model is designed specifically for students with little to no prior HPC experience and is intended to serve as a gateway into high-performance computing. The training follows a weekly session format with basic Linux terminology and Unix philosophy before progressing into more advanced topics such as parallel computing and optimizing practical applications for high-performance computing. Lectures usually build up upon each other, eventually integrating all the topics taught over the span of the year. These sessions are complemented by weekly tutorials, usually consisting of a research component where students are asked to research a topic or report on their findings, as well as practical exercises involving compiling and optimizing or parallelizing an application. The goal is to reinforce what students learn during the talks and enable them to apply it practically, forcing some sort of hands-on experience. Students selected for the National SEC take a slightly different path from Wits' side. In the third quarter, they get thrown into the deep end, having to configure hardware from the ground, slotting RAM, repasting CPUs, encouraging them to learn and inevitably make mistakes that they hopefully won't make in the national competition. In previous years, our training model was heavily geared towards preparing students for the national SEC. However, in recent years, we've expanded our focus to cater a broader audience of students that are interested in HPC for their research, but might not be eligible to compete in the conference or haven't been selected for the competition. The aim of the training, as mentioned, is designed as a blueprint for self-study, not aiming to be a definitive guide or a formal course.
Cool. So we've expanded to general undergraduate education, but yes, we still are mainly geared towards selecting teams for the SEC. So now we're going to talk about what that selection process is. So in previous years, we used to have a selection quiz, which was just an online open book test based on shell scripting, and it was Linux based. And we would just choose the top performing students, but we'd also take a look at their transcripts, and they had to write motivation just to make them well balanced and that they would gel together. This year we tried to spice it up, and we did a project, and we made use of the Open HPC lab that Brian talked about earlier to deploy a 3-node cluster. And on that cluster, they just ran a small little parallel program. And they had 4 weeks to submit build and run scripts and their output files. We wanted to try simulate the SEC a bit. So then they would get scored based on the scripts they submitted as well as their runtimes, obviously more weight towards the runtimes. And then once again, like the quiz, you look at the transcript, the motivation, and you just see, you choose the team such that they'll work well together. Then after the selection round, okay, if our teams make it through, then we start preparing for the national round, which is held at this conference. And in order to do that, at WITS, we have some decommissioned old hardware from HPC ecosystems, and we use that hardware to set up 3-node clusters at WITS, and the students do this. And this gives them some hands-on training with HPC environments, which helps them build skills like operating system installation, networking configuration, package management. And once they've set up this cluster, then they have to learn how to compile and run the applications on the cluster. And because it's all within WITS, us, the mentors, can provide technical advice, and we can also just help them set objectives for what to do with the apps. So that's how the workings go. Let's talk a little bit about what's not going so right, our challenges. So our first thing is we have decreased participation in the second half of the year, and there's multiple reasons for that. But one of them is once a student realizes they haven't made it into the selection round or the national team, they lose motivation to keep coming to the talks. Another thing is academics get tougher towards the end of the year, so you want to shift your focus to them. And the last thing is our topics do get more advanced later on, and that decreases interest. Then once again, with our new selection project this year, we noticed decreased participation, which kind of was the goal. We wanted dedicated students to show up. But we're going to try and make it more enticing by turning it into a whole competition with some sponsored prizes. I'll now hand our last challenge over to Reynard, and he'll talk about our future plans.
As for the decommissioned hardware that's showing its age, a goal for 2025 is to repurpose a small cluster at WITS in collaboration with HPC ecosystems that would be more accessible to all the students in the SIG, where we will host competitions, applications, and some of the SIG talks throughout the year to allow not only students that are in the challenge itself, in the student cluster competition, to work on nodes, but also have students work on a computer that is available to a much larger audience. We'll move to Lily for more future plans.
So we're very eager to try and participate in more international competitions, and our goal for 2025 is to compete in virtual ISC, and we want to try and get to ASC. So just some context on the two, the ISC Student Cluster Competition now has a virtual component. We've submitted our application for that with a team that has experienced past participants and some new participants from the cluster competition downstairs. ASC, they provide the systems as well as the accommodation, and we just think it's the next logical step in trying to participate internationally in person. For the other ones, SC and IC, we plan over the years to collaborate with hardware sponsors so that we can get systems to be there in person. But for now, it's ASC 25 and ISC 25. And lastly, papers.
The structure's a bit weird, but basically, we also plan to release more material, so just papers and posters. We have one accepted paper, one published poster as a group, and we're moving on to Perk 25, hopefully having a poster for that. Thank you.
Cool, thank you. If you want to check out what we're doing, when our paper will come out, we'll post on all our socials. So if you just want to follow us and what we're currently doing in the space, you can take a photo of the slide. Thank you.